Now, the first time the senior scientists in the lab showed me the data, I thought, well, there's absolutely no way this is real. So run it again on another set of samples and run it again on another set of samples. And this exact pattern continues to repeat. So it's a dramatic change in the cores, which is why cores are now the preferred rather than curls.
In regards to the procedure that is the second challenge, we have all these considerations in our protocol. Which extraction kit to use, and we've pretty much tried them all. Different organic, column-based beads, magnetic particles, workflows where we've primarily been manually. Up until the last 6 or 8 months, we've been developing our automation system with Covaris. There are many different steps that are listed here on the right side that can help or hinder depending on how well or how efficiently you're going through them.
What does it look like as a punchline? So the optimized protocol, you can see, here's the old way, the standard protocol. 22 out of the 95 samples had a DV200 of greater than 20%. You can see the ones that fall over this line. In this case, this is sections, so these are the curls. Pretty dramatic improvement. There was only one sample that fell below, so 89 out of 90 had a DV200 of greater than 20%, with, in fact, most of them quite a bit higher. Almost the majority is over 40%. So a dramatic improvement. Obviously, these longer RNA transcripts should yield better representation of the transcripts and potentially less bias in the downstream analysis. And of course, certainly a much, much higher success rate through the overall protocol.
Like it's always said, garbage in, garbage out. So if the quality of your RNA and DNA is extremely poor, the assay is not going to work well, you're not going to get good data.